All right, so again, we're still simplifying radicals, but we're going to be talking about the imaginary number now, and that comes from when you're taking the square root of a negative number, okay? So the very first thing is the square root of -1 is equal to I, the imaginary number, okay? Lowercase I is what we're going to be using. And we're going to first start talking about powers of I, simplifying I to the 73rd power, okay? And how to do that. These you will have to remember, but also I'm going to give you a little trick as to make it easy to remember after we talk about the first powers of I. So, all right, again, the square root of -1 is equal to I. When we simplify radicals with imaginary numbers, we're going to split them apart like we did with our non-perfect squares. But again, we're going to talk about the powers of I first. So I to the first is just I. Okay. We don't ever leave a square root of a negative. We always replace it with I. And then I squared is going to be I times I. And we'll think about this. When we do, let's say, when we do the square root of 2 times the square root of 2, what does that end up simplifying to be? Just what? You get the square root of 4, which gives you 2, right? So if you have the square root of -1 times the square root of -1, kind of keeping with the same pattern, what do you think it would just be? -1. Okay, so I squared is equal to -1. And then I to the third, we get from multiplying I to the first times I to the second. Well, what did we call I to the first? Just I. And what did we call I squared? -1. If you do I times -1, that just gives you -I. And then I to the fourth, we can get from a couple of different combinations. I'm going to do it from the one that I think is the easiest to see, and that's I squared. Maybe. Of course it did. Let's try that again. There we go. Okay, try this again. So we're going to go I squared times I squared. That gives me I to the fourth, right? Like x squared times x squared is x to the fourth. Well, what did we say I squared was? Look back up. What is I squared? -1. So basically that's -1 times -1, which gives me a what? +1. So we've got I to the first is I squared is -1. I to the third is -I. And I to the fourth is 1. Okay, well, let's do this. Let's do I to the fifth. Which two of the first 4 could I multiply to get I to the fifth? I to the first, maybe, and I to the fourth? Or I squared and I to the third? Right. So let's do I to the first times I to the fourth. What did we say I to the first was? I, and I to the fourth we said was 1, and 1 times I is just I. Well, that's the same thing as I to the first, isn't it? Okay. Let's look and see if that happens again. I to the sixth. What do you think? We'll go I to the fourth times I to the sixth. Does that work? Okay. Not the 6. I squared times I to the fourth. That gives me I to the 6. I'm sorry. I said the wrong thing. And what is I squared again? -1. And I to the fourth we said was 1. So if I multiply -1 times 1, I get -1. So does that seem to be following along the same pattern? So what do you think following that pattern I to the 7th would be? -I. And then I to the 8th would be 1. Okay. the pattern repeats after the first 4. You don't have to memorize the first 8. You only have to memorize the first 4. So again, I to the first is just I. I squared is -1. I to the third is -I. And I to the fourth is 1. And those patterns repeat after every 4. So what we're going to do is we're going to simplify I to some large power, okay? And we're going to either give one of these 4 answers, I, -1, -I, or 1. So let's take a look, whoops, at the first one. I'm going to show you how we think through it, and then after we do that, I'm going to give you a little bit of a shortcut on how to simplify these. Okay, so if my pattern repeats after every 4, we could basically just count, right? So if we're going to find I to the 17th, I'm going to use these 4. I to the 1st, 2nd, 3rd, 4th. This one is the same as I to the 5th, I to the 6th, I to the 7th, I to the 8th, correct? So we'd go back up. I to the 9th, 10th, 11th, 12th, 13, 14, 15, 16. So I to the 17th would be the same thing as I to the 1st, which is just I. Okay. So I can always count using those first 4 and just count till I get to that exponent. However, when we get into large numbers like 27 and 34 and 100, we don't want to have to count that many times, right? Okay, so this is what I do. When I'm thinking through this, I want to think, what is the number closest to 17 that 4 goes into, but smaller? Okay, so the number smaller than 17 that 4 divides into evenly. 16. So that means I to the 16th is going to be exactly the same thing as this, which then leads me to taking I to the 17th up here, if that makes a little bit of sense. Okay, so let's think about this one, I to the 27th. I want to think of a number smaller than 27 that 4 goes into evenly. What is the closest thing to 27 that 4 divides into evenly? 24? Okay, so that means this is I to the 24th. So this would be I to the 25th, I to the 26th, I to the 27th. So what would that simplify to be? -I. So I want you to try the next one. Try I to the 34th. Again, think of the exponent. What is the number closest to that 4 goes into evenly? Start at I to the 4th and then count your way. We're thinking about what number closest to 34 without going over does 4 divide into evenly? What number closest to 34 does 4 go into evenly? 32. So that means I to the 32nd is here. So I to the 33rd would be here. And I to the 34th would be here. So that would simplify to be just what? -1. And then the same thing with I to the 100th. What's the closest number to 100 that 4 goes into? 100. So that means it's going to be exactly what I to the 4th is, which means it would just be 1. Bless you. Now that's the way you think through it, but I'm going to give you an easier way to do it. Do me a favor, somebody that has a calculator right next to you. Take that exponent 17, going back to the first one, take the exponent 17 and divide it by 4. And I'm looking specifically at the decimal. Not whatever's in front of it, but what is the decimal there? It's 0.25, right? Okay. Do the same thing for 27. Do 27 divided by 4 and tell me what your decimal is. 0.75. We said that was this one, right? Okay. What about 34? Do that divided by 4 and tell me what your decimal is. Okay, we said that one was the same thing as this. And then if you do 100 divided by 4, you don't have a decimal, right? Or just 0.00. Is everybody okay with that? Okay. Now, what I want you to do is we're going to think about what kind of relationship we can. If my exponent is 1, it's 0.25. If my exponent is 2, it's 0.5. If my exponent is 3, it's 0.75. If my exponent is 4, then it doesn't have a decimal. What does that kind of seem familiar to that is divided into 4 parts? 25, 50, 75. Huh?
A coordinate plan?
No, I'm thinking something you use every day. If you have one of these, it's 0.25. If you have 2 of them, it's 0.50. If it's 3 of them, quarters, right? So you can think about it like that. You can divide whatever the exponent is. So let's say I give you I to the, 123. Okay? And you want to simplify it, and you don't like the way I told you earlier about thinking through it. All you have to do is take that exponent, 123, and divide it by 4, and focus on the decimal only. Is it 1 quarter, 2 quarters, 3 quarters, or none? Then it correlates to which power of I it is. So if you did 123 divided by 4, what would your decimal be? 0.75. So that's going to be the same thing as I to the third, which is just negative I. If my pen would actually write like it's supposed to, it might help. Does that make sense? Okay. So sometimes it's easier, or people find it easier to just use their calculator, take the exponent given, divide it by 4, and then match it to which one of these first 4 it is. Is it 1 quarter, 2 quarters, 3 quarters, or none? Then it would correlate to which the power is of I. Is everybody okay with that? Okay. All right, now we are going to start talking about actually simplifying with our imaginary number, simplifying our radicals. So we will, again, get to use our roots on this test. I'll have the chart still. I'll give it back to you when we take the test. But all of these are going to be simplified with the imaginary number I. We do not want to try to get a decimal, because if you did the square root of 16, negative 16 in your calculator, it's going to tell you it's not real. It's going to tell you domain error. So this is the very first thing I want you to do. Anytime there is a negative under a square root, the very first thing I want you to do is I want you to split it up into the square root of negative 1 times the square root of that number. And then we're going to continue to simplify. Is it a perfect square? If not, what perfect square goes into it? But first, what is the square root of negative 1 always equal to? I, right? And then is 16 a perfect square? Yes, what is the square root of 16? 4. Okay. And because that was a perfect square, we don't have a radical left. And if I multiply I times 4, we basically treat it like a variable at this point. How would I write it? 4I. So the square root of negative 16, we can now simplify. We're not going to say not real anymore. We're going to do it like this, and we're going to give it the answer as 4I. Go ahead and try 6 then. Always break it apart into the square root of negative 1 times the square root of the number. And then simplify like we have been doing. The only difference is we're going to have the I involved in our answer. All right, splitting it up again, square root of negative 1 times the square root of 64. And again, the square root of negative 1 is always going to equal I. Is 64 a perfect square? What is the square root of it? 8. And so if I multiply I times 8, I just get 8I. All right, let's talk about 7. First of all, split it up. Negative 1 times 6, the square root of negative 1 times the square root of 6. What is the square root of -1 again? I. Is 6 a perfect square? No. Does it have a perfect square that divides into it? Think about your perfect squares. 4, 9, 16. Evenly, though? No. Okay. So 6 cannot simplify. So what we do is we leave that under the radical. And so your answer is just I times the square root of 6, because we cannot simplify the square root of 6 unless we get out a calculator. And we don't want decimals. We want to leave these in what we call simplest radical form. Is everybody kind of okay with that? All right. Let's take a look at 8. We have the square root of -24. First things first, break it apart. -1 times 24. And again, what is the square root of -1? I. Is 24 a perfect square? Does it have a perfect square that divides into it? What? 4. So what we're going to do is we're going to split that 24 up into the square root of 4 times the square root of what gives me 24? 6. And then we're going to continue to simplify like we have been doing. That I is going to stay I. What does the square root of 4 turn into? 2. And that square root of 6 stays like that. And then to put this all together, I times 2 square roots of 6. This is how I write it. I always put the number first, then the I, then the radical. And our answer is just going to be 2I times the square root of 6. Everybody okay with that? All right. Try 9.